is that this poor woman, yeah, so all the DJs were telling this woman to and the fellow contestants drink the water and who would be the last one to use the restroom. And yeah, she died of water intoxication when she came home. And this is crazy. Like this guy, one of the contestants, he said they were given 5 bottles and he given even more bottles. A nurse actually called into that radio station to tell them, "Hey, you gotta stop this. This can be potentially fatal," and it was. And the really sad thing is that she actually had kids, and she was wanting to win the Wii for her kids. So again, it's like really sad, but shows you, yes, it is good to drink your 8 glasses. And by the way, that's kind of a myth. And also, like, it's good to drink your and stay hydrated and not be dehydrated, but it is possible to drink too much water. Now let's talk about endurance sports, so marathoners and water intoxication. So why do they offer things like juice or like even for ultra marathons, they give them like Gatorade, like those crazy people who do, and I don't want to say crazy, but the hardcore people who do like those 100 or 250K races, but they notice that they don't give them pure water, or if they do give them pure water, they also give them something to eat. But why? Again, they want to prevent that water intoxication and hyponatremia. So what could happen to marathon runners if they drink distilled water versus Gatorade or something or eat something with water? Well, things like sweating. Well, things that during a marathon, what happens? You're sweating, right? So when you're sweating, remember that previous figure, you are losing water. So not only are you losing water, but remember what else is in sweat? Enzymes and other things. But what caused, or have you ever like done a workout outside or went to the beach, sweated so much, and later on you found out that your sweat has actually dried and see all the salt crystals. So when you sweat, you lose water, but you also lose electrolytes as well, such as sodium and chloride and all the other ions. Now, if you drink plain water, what happens? Well, and again, this is shorthand for concentration. So if you drink plain water, what happens? Well, again, when you hyperhydrate, you reduce your ion concentrations and your electrolyte concentrations as well, right? So you're going to lower your sodium concentration. You're also going to lower your concentrations of all the other solutes in your plasma and interstitial fluid. So what happens if you're drinking plain water with no electrolytes and also sweating? You're causing a major decrease in sodium and solute concentration. So this is why for endurance sports and marathon runners, that's why they don't give them pure water and nothing else. Why? Because this is going to drastically lower their solute concentrations in their bodily fluids. So yeah, this poor guy, I think, yeah, only 22, running his first marathon, and he died from drinking too much water. Again, sadly, he probably wasn't getting enough electrolytes. Now, we know how that can be toxic to the brain, right? Because again, your neurons need the sodium, that initial rush of sodium to do that action potential. But what other action potentials have we talked about this semester? Hey, does this sound familiar? So again, conducting cells, and they have their own action potentials, and then they trigger action potentials in atrial and ventricular cardiomyocytes. And what do you see here? All of these ions are moving throughout these cells, right? But again, what is causing an action potential? What happens if you have low sodium? Well, one, you can't have propagation of conducting cells to atrial and ventricular cells, but let's talk about the action potential itself. Again, remember, let's talk about pacemaker cells. So pacemaker cells, again, they have that pre-potential, and what happens during that? Well, again, it's trying to reach that threshold. Now, what happens here? Again, typically in a healthy electrolyte balance, you have more sodium on the outside, less on the inside. What happens? Well, we're gonna remember those pacemaker cells. They have that pacemaker current or that funny current, and this allows a little leakage of sodium and potassium. Again, don't worry too much about potassium, but for this one, let's talk about sodium. So it does allow sodium to leak through, and again, it's going to leak through from high to low concentrations, right? So what's that going to do to membrane potential? Well, again, the more positive a cell gets, the more positive the membrane potential becomes. And remember that sodium channels, these funny currents, open another type of channel called a calcium channel. And what happens? Well, again, more calcium on the outside, less on the inside. So when you open these channels, due to the change in voltage, now you have calcium flowing in. Now this brings it closer to the threshold. Now you get that memory potential going up to the threshold, and then boom, action potential in a pacemaker cell. Okay, that should be reviewed. Now, what happens if you have low sodium? Again, you have overhydration, or let's just talk about low sodium. Right, so let's talk about low sodium, and what about this? Now we have more sodium on the inside of the cell, less concentrated on the outside. Now the sodium ion can't get inside the cell. Can we still do an action potential in pacemaker and conducting cells? Well, again, if it doesn't reach the threshold, yeah, and another thing is that we need that to reach that pre-potential, that midpoint right there, to actually open these calcium channels. If you don't even have that increase in that membrane potential, these channels stay shut. So you don't get that additional push through threshold. So what happens? Yeah, no action potential. Why? You didn't reach the threshold because if you over dilute the sodium here and these calcium channels are closed, or even worse, if the calcium concentration is more diluted and less due to overhydration, then you're not going to get action potentials. So again, no action potentials due to not reaching threshold. Now, what does that mean for your heart? So again, no action potential due to low sodium. Why is this potential lethal? Well, no action potential, no electrical activity, no calcium release. No calcium release, no binding to tropomyosin, and no binding and troponin and tropomyosin, and no actin myosin binding in the heart, no heart contractions. So, no heart contractions, what does that lead to? Cardiac arrest, right? So again, this is why those ions matter. Again, it's all building upon itself. And I know everyone loves action potentials, but if you mess up your solute concentrations and electrolyte concentrations, you can't do any of the muscle or neural activity. So again, your brain, your heart needs ions to do these action potentials and to perform their normal function. Okay,